Hey guys, before this video starts, I just wanted to go on ahead and tell you guys that I am no expert. What you hear in this video may be incorrect in some way or form, but at the end of it, I got an understanding of what I'm doing and where I'm going with it. So if you like the video, please continue, and I hope you enjoy. Hello YouTube, my name is Crumb or Glenn for the win, and in today's YouTube video, we're doing a little bit of game hacking to understand how memory works. So the first thing that I'm going to do is I'm using AssaultCube because it's a good reference for game hacking whenever you're first learning out. And I'm going to be using Cheat Engine to look at the different memory addresses within AssaultCube. So we're going to go on ahead and click this up here and click AssaultCube so that we can attach to that value, to that application. Next, we want to input the value for our health. So let's say we want to find our health value and edit it or make ourselves a god mode. We're going to go on ahead and find our health value. So we're going to put 100 in here for our health value, and we're going to give it a first scan. You'll see a bunch of integers show up on here, and a lot of these, we don't want to go through every single one of these to find out which one of them is our actual health value or not. So to make it easier on ourselves, we're going to go on ahead and hurt ourselves to lower our health value, and you'll see now it's gone down to 64. So we can go on ahead and type 64 in here and do another scan within the scan so that we can see which values changed to 64. And just like that, we have two values here. One of them actually draws the text to the screen for the health, and one of them is the actual integer for the health value. So we're going to go on ahead and I know that the top one is going to be the health, so we're going to go ahead and add it to there. And we can test this by changing 64 to, let's say, 6400. And if this changes correctly, if this changes to 6400, then we know that this is the health value. And just like that, it changed. So we can take this further by finding out what accesses this address. This is going to tell us what the health offset is, as well as the local player pointer. So we go ahead and click this and click yes to enable the debugger onto the application, and now we get this output. We can see a bunch of this random code with instructions and an identifier with an offset value. So what we're going to do is notice this offset right here. This is in hexadecimal format, but this offset would be 0xEC or EC. So to find the local player for this offset, we're going to go ahead and hurt ourselves again to see what EC writes to. So we go ahead and hurt ourselves, and we can see that EDX plus EC is the EDX is the local player pointer. So we're going to go ahead and take EDX right here, and then we're going to add this address manually, just like that. And we're going to name this local player pointer. And we'll also name this one, we'll give this one a name, we'll call it dynamic memory address. So with the local player pointer, we can go ahead and find out more information about our offsets and what the pointer for the health value is. So let's first find the pointer for a health value. We're going to take this address right here, and we're going to put it into here, and we're going to add it into a hex value, just like that. So we're going to do a new scan, and we'll see we have this output. And we have 4 of them that are green, and the rest of them are white. This means that 4 of all of these, 4 of the 43 found is static. So these always stay the same. And if we hover over them, you can see the base address plus another memory address that goes with it. Alright. So we're going to go ahead and add these into here, and we're going to change these from hexadecimal to normal values, just like this. Alright, and you might be confused and wondering why this isn't showing our health value, and that's because this isn't correlating to our health value yet. To find that, we're going to go ahead and take these addresses again, and I'm going to do a pointer scan for them. So we're going to enable this pointer right here, and right here in the instructions, we're going to put the offset, EC, just like that. And we're going to do this for all of these. Okay, and so here we can see 4 pointers that successfully point to our health value. So I can change any of these pointers to change my health value. So we only need to worry about one of these. So we're going to cut these guys out. Next thing that we want to do is find more offsets. So we're going to take our local player pointer and browse the memory region within it. We're going to go to Tools and dissect the data structure. Here we're going to go to Structures and define a new structure. You'll notice that it already gave it a name called player int. This is player entity. So we're going to press OK, and we'll see that we have a bunch of offsets over here on this side, as well as the address and the value over here. And this tells us that this is the X coordinate, Y coordinate, and Z coordinate for our game. And we can verify this by moving around. So if I jump up, that value goes up. If I go forward, the X value goes up. If I go left and right, the Y value goes up. So, and you'll notice that all of these are floats. So we can add these to our memory list, and we can do this pretty easily too without having to worry about these address lists. So we're going to go ahead and go back to our pointer right here, and we're going to copy this bottom base address and the memory address. So we're going to do an add address manually, and we're going to put our address in right here and enable pointer. Next, we're going to enter our offset for our coordinates. So let's say we want to find our X coordinate, which is going to be offset 4, and in hexadecimal it is recognized as 0004. So we're going to do 4, and then we're going to change. You'll see that it's not the same. That's because we're still in bytes, and this is a float. So we're going to change the type to float, and you'll see now we are successfully getting back our coordinates. So we're going to go ahead and do this for all of our coordinates. So we're going to name this X coordinate, okay, and then I'm actually going to name this base pointer. We're going to take this again, and we're going to get our Y and Z coordinates. So we're going to put this in here, and then right here we're going to change this to our Z coordinate, which is, our Y coordinate, which is 8. And then change this, it's still on a float, so there we go, we have our Y coordinate. The next thing we can do is name this Y coordinate and get our float for our Z coordinate. So we're going to input the same pointer again, and it automatically guesses that's the pointer that we want. And then we're going to do a pointer and change this to our offset for the Y axis. So I want you to guess, before I say it, what the offset is. The offset is C, and it gives us the value, which is 2.5. So now you'll see if we move around, these values will change. And now we can find more pointers by just scrolling down this list and looking at what we got. So let's say we wanted to find the value for our gun, our health value, or our ammunition values. So we have 2 values here. We have a value for the ammo that is currently in the gun, and the ammo that is in the magazine, how many magazines we have left. So we're going to scroll down and look for 13 and 40. And right here we found 13, and here is 40. So we can identify and see if these are the correct addresses by simply changing this, and we're going to change this to 999. And you can see that our ammo has changed to 999. And we're going to do the same thing for the magazine, and it changed the ammo to 999. So we can confidently say that this is the magazine ammo and this is the actual ammo. So we're going to make two new pointers, and we're going to use the same base that we used, and this time we're going to change this to the offset for these things. So you can guess what the offset for this first one is. I have a crack on my screen right there, but I think that this is a C. So that's going to be 11C. And then you can see that it gives us this weird output. And that's because we didn't change this back to a byte, 4 bytes. So if we change this back to 4 bytes, it turns to 999. And then we can name this magazine ammo. Next, we can find our bytes for our normal magazine. So we can just do this again. And then we're going to do 140 for the offset. And there it is, 999. And we'll change this to ammo. Now we can freeze all these in place and just use this as our mod menu if we wanted to by just checking these. I wonder what checking the coordinates do. Will that freeze me in place? No, it won't. Okay. So we can freeze our magazine ammo and our normal ammo. Oh, I changed to the wrong gun. So as you can tell that the pistol magazine has different value offset than the than the rifle magazine. So if we shoot this, you'll see that it stays at 999 relatively. Now this works in theory, but whenever you're looking for your health, which I didn't include here, I should have included this. So we're going to take our base pointer here and we're going to add our address for our health value, which is right now our health is 100, and we know that the offset for it from finding out what accesses the address is EC. So we're going to do a pointer and do EC right in here, and then we'll call this health, just like that. So now we can make our Python script that will go to all of this information. But there's one crucial part that we're missing out. You'll see that this says ac_client.exe plus, and then this. Well, this is represented by a hexadecimal value as well. And we need that information for the base address. So to get that information, we're going to go in here and we're going to press, I believe, browse this memory region. If I can get this screen to open up, it's being confusing for some reason. And then we can go to tools and we can look for dissect PE headers. And in here you can go on ahead and see the base address for ac_client.exe. And to make sure that this is the preferred image base, we can go ahead and press info and go into the PE headers right here and scroll down a little bit until we see preferred image base, which we can see is 004 or OX 400,000, I mean, whatever you want to call it. So now that we have this information, we can go ahead and start writing a Python script that will automatically find all of these offsets for us. So to do that, we're going to go on ahead and make a new text document, and we'll just call this edit.py because we're going to be editing values. So we're going to edit this with Notepad++ and bring this back over here, as I have Notepad opened up in another window. So right here, we're going to be using pymem and OS to do this. OS isn't required, but it's just nice so that we can use it to clear the screen so that we don't get too many print messages. So we're going to import OS, import pymem, and import pymem.process. The next thing that we have to do is find the process name. And we know the process name, it is, where's Cheat Engine? Did I close Cheat Engine? No. Our process name is going to be ac_client.exe. So we're going to type process_name equals, and then in quotation put ac_client.exe. The next thing that we have to do is get the base address from ac_client.exe. And we know that it was 400,000. So we're going to do base address equals 0x400,000. You don't have to include any numbers that are in front, any zeros that are in front of the base address. So if we go back into here and look at the Dissectpedia header one more time, you'll see it has 0, 0, and then 400,000. You can ignore the 2 zeros, and instead of that, you can just put 0x. Okay? And so the next thing that we need to do is get the local entity pointer offset, which we already got, and was it was this 17E0A8. So we're going to copy this, and then we're going to do local entity pointer offset equals 0x and then our offset. And now we want to include the actual offsets for our health, ammo, and magazine. We're not going to worry about our coordinates. I'm going to make another Python script that's going to read that information and display our coordinates. So we're going to do offset underscore health equals 0x, and we know the offset health is EC. And then we're going to get the current ammo and the magazine ammo. And we know that the current ammo is OX140, and the magazine ammo was OX11C. So we go on ahead and type offset current ammo equals, and then that. And then we do offset and then magazine ammo equals that. Just like that. And now we're just going to go ahead and create a function to clear the screen, which is no biggie. Alright, so now we need to make a function that'll get the local entity address. So we're going to do define get local entity and then address, and then we're going to type module equals pymem dot process dot module from name, and then we're going to do pm dot process underscore handle and then process name, just like that. Next thing that we have to do is do base equals module dot lp base of DLL, just like that. Now what this does is this gets the module information for the process. Now we need to read the pointer to the local entity from the calculated address. So we're going to type local entity, if I can type, local entity, and then we'll type add r for address equals pm.read underscore integer, and then base plus local entity pointer offset, just like that. And then we're going to return, to local entity address. And just like that, the function for getting the local entity address is done. Next, we need a function to change the values. So we're going to do define change value, and then here we're going to type pm, and then we're going to type local entity address, and we're going to type offset value and then value type with a semicolon at the end of it. And now we need to do if value underscore type equals integer. So it's going to write an integer value for the specified offset. We're going to write pm.write integer and then do local entity address plus offset comma value. And then we're going to do print value at offset. And then in here we're going to do hex, and then we're going to do offset. And make sure that you use brackets for the outside, like that. And now we need to do set to and then type, in brackets again, type value. Just like that. And now we need a elif function for if the type isn't an integer, which would be represented as a byte, but it's a float. So we're going to type elif value type equals, and then in here we're going to put float, and we're going to type pym.write underscore float, and then we're going to type local entity addr plus offset equals value. And now we're going to print f value at offset hex, and then inside of here we're going to type offset just like that, set 2, and then we're going to do value like that. And just like that, that is done. Now we just need the main function, which is going to be used to actually show the menu and do the actual writing. So we're going to do define main, try pm equals pymem dot pymem, and then we're going to put in process underscore name, and then next we're going to do local entity addr equals get local entity address, and then put pm at the end of it, and then we're going to do while true, and then here we're going to include our clear screen function, and we're going to print some messages. We're going to print AssaultCube mod menu, and then we're going to print select an option to modify, and then type print, and then for this first one we're going to put health. For the next one we are going to put current ammo, and then for next we'll put magazine ammo, and then lastly we're going to print an for to exit. All right, and now we're going to do choice equals input, enter your choice. And now we need to give our choices. So we're going to do if choice equals and then 1, then clear the screen, and then do new value equals integer, and then input, enter your new health value. Just like that. And then we got to write an integer value to the specified offset for the health. So we're going to do change value, and then do pm local entity address, and then offset health, and then do new value, and then type integer because the health is recognized as a byte or an integer. And then we're going to do input, press enter to continue. And now we can go on ahead and do the next options, which is elif choice equals 2. And clear the screen. And then do new score value equals integer, input, enter your new ammo value. Just like that. And then we do change value And then this is pretty much all going to stay the same right here. So we're just going to copy this over. And then instead of offset health, we're going to change this to offset current ammo. And it can stay as an integer. And then we're going to copy this input again, just like that. And now we can do the next option. Bless me. So option 3, we're going to copy this information and then tab it into the correct tabs. And then here, we're going to enter your new magazine value. And then here, we're going to change this to offset magazine ammo. And I saw that it didn't tab right there, and I see a mistake that I made. So I'm fixing that. So, see a magazine ammo right there, and it can stay as an integer because it is still a byte. And then the next thing that we're going to do is do elif choice equals 4. And then we can do clear screen, and then do print exiting, and then do break else print -in invalid choice. Press enter to continue. All right, and now for the bottom of the script, we're gonna get out of this and do except pymem dot exception dot memory read error as e print memory read error, and then type brackets e. And now we can do except pymem dot exception dot memory write error as e, and do print f. Well, you don't have to include f. Memory write error, and then do e. And then we can do except exception is e print an error occurred, and then error. And then we can call this back to the main. So we're going to do this. Quit playing with me. Just like that, and then we're going to call it back to main. And just like that, this is done. So we're going to go ahead and go into CMD, type cd desktop, and then python edit.py. Hopefully I didn't make any mistakes. Of course I did. Right here. And then on line 16, what did I mess up? Get local entity address. So right here, we have to do this and do pm semicolon. Line 32, I messed up again. Local entity add r equals get local. Let's see where I messed up. I'm dumb. just like that. And another issue, of course, we didn't have this. Okay, so after fixing a few errors that I made, this should work correctly. Memory read error. So I can see right here the local entity pointer offset. I put this in wrong. So we're gonna go back in a cheat engine here, and we're gonna get our local pointer right here. We're going to put this value in right here, and now it should work. There we go, just like that. So now we're going to go ahead and go into the game here, and let's change our health to see if this works. Do 999, and now our health is 999. Do this again, change our current ammo. Let's change this, since it's already at 999, let's change it back to 100. And it didn't change anything. Ooh. Oh wait, oh, I know why. It's because in cheat engine, had me confused for a second. In cheat engine, it's still frozen. So we just uncheck that, go back in here, 100, and then go, and then hit 3, 100, and then health, 100, and there we go. You can see it's working. And now we need to find out how to get the coordinates and display them into terminal. So let's go on ahead and do that. So to make a Python script that will show our coordinates in terminal, it's pretty easy. All we have to do is make another text document, and this time we'll call it chords.py. Edit it. And we're going to follow the same process that we followed before. So I'm actually going to go back into edit.py right here. And I'm going to copy this information, and I'm just going to paste it over like that. Alright, and now we just need to input our offsets for our x coordinate, y coordinate, and our z coordinate. So let's go ahead and find these again. They are right here. We can just go ahead and look at this and look at the instruction. So for x, it is ox4. For y, it is ox8. And then for z, it is oxc. Just like that. And now we're going to do previous chords equals none, and then define our clear function again. We're gonna just copy this. And now we need a function to read the coordinates. So we're gonna do define read coordinates, and then do global previous chords, and then do try. And then we're going to try to open the process. And then we're going to get the base address of the module. So we're going to do module equals pymem dot module from name pm dot process underscore handle, and then process name. And then we're going to return this by doing base equals module.lp base of DLL. And now we're going to do while true. And then we're going to calculate the address of the local entity. So we're going to do local entity address equals pm.read integer base plus local entity pointer offset. And now we need to read the coordinates using the offsets, and we need to remember that these are floats. They're not binary, they're not bytes, they're not an integer. So we're gonna do x chord equals pym.read float, and then right here we're gonna type local entity add r comma offset x chord, and then we're going to do the same thing for the y and z coordinate. Change this to y, change this to z, and then change this to y, and then change this to z, just like that. And now we need to compare with the previous values. So we're going to do if x chord, y chord, and z chord greater than or equal to, or I don't mean any address or equal to previous chords, and then we're going to type previous chords equals, and then in here we're going to type x chord, y chord, and z chord, and then we're going to clear screen, and then we're going to print the coordinates. Just like that. And then we can include our exceptions again. So we're going to type except pymem.exception.memory read error as e, print, and then we're going to print memory read error, and then type e, and then we're going to type accept exception as e, print, and error occurred, and then e, and then we can just call back to main again. Just like that. And now that is done. So we can go on ahead and double check everything. We'll let Python double check everything for us. So we're going to type python chords.py, cd desktop first, python chords.py, an error occurred. Great. Okay, what's wrong? Process name, base address, local entity, pointer offset, offset x, offset y, offset z. Let's see. No, it's supposed to be like that. Okay. Forgot a bracket right there. No? Okay, guys, give me a second while I figure out what's the issue. Okay, after reviewing my code a little bit, I know that the issues is with this line right here. And we're going to type process.module from name right here. And then right here where this says commas, this is actually supposed to be pluses. And this while true statement should actually be capitalized with a capital T. Okay, so now the script should work. Interesting. Why is it printing like that though? Okay, so for further explanation, I found out that this was printing because it didn't include this F right here. So if we just do like this, you'll see it comes up like this. But if I put this F right here, it'll show our coordinates, just like that. So if I walk around, we will see our coordinates change with it. And yeah, that's how you do that. I'm sorry I couldn't really explain this that well. I'm still learning just as you guys are. This is a video mainly just for me to recap on what I have learned. If you enjoyed, please like and subscribe. If you didn't, tell me why. Try not to be hateful. I mean, we're all here, we're all learning. Maybe you could give some pointers or some information on what I could do better. But thank you guys for watching. Thank you guys for being part of this learning process with me, and I'll see you guys in the next video. Peace out.